audio. Let me just get the PowerPoint open and then I will start to let people in. Ooh, 4 people in the waiting room. Crazy. Okay, give me a second. Come on, Mr. Rain, you got this. Okay. Sign out. Okay, sign in. Mr. Main. Wow. Okay.
The only area is getting snow.
I don't know if we're the only area getting snow. Class, and all I want to do. Classroom. School, instructions. Boom. Okay. So here we go. I'm going to start to let people in. Diego is here. Hi, Diego. Let me just let a couple more people in. Olivia and Willie. Diego. Jaden Ramos. Lily. Ethan. Gabby Campany. Oh, Hazel. Gabby and Isabella. And who was that last person? Gabby. So we should have 8 people. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay. So people at home, if you wouldn't mind, please either taking out your textbook or opening up your slideshow to today's slideshow. The textbook we're opening up to lesson number 7. Let me just grab this one here. We're opening to lesson number 7. Give me one moment. Let me just get there. Lesson number 7. And we're going to look at the next activity 2. Are they similar? That's where we're going to start today. Are they similar? Let me look at the slideshow and we will follow along with me. I don't even think I'm sharing my screen yet. I'm sorry about that. Here we go. And I'm going to come here, do this, pull this down here. And let's take a look at our warm-up for today. So the warm-up for today, it's activity 1. Let me just find the clicker so I can unfreeze this guy. Come on, come on, come on, come on. There we go. So we can unfreeze this guy. Brando is here. Wonderful. And we're looking at this warm-up here. So the warm-up, are some, none, all are congruent. So let's take a look. I want to pull this chat up. I usually try to leave it up. We're on lesson 7. Lesson 7. Okay. So we have to choose. You don't have these triangles in your book, but I added them so that we had a little bit of a visual here. So we need to choose whether each statement is true all the time, in all cases, in some cases, or in no cases. So if we have, two figures, if they are congruent, then they are similar. So remember, congruent means same size, same shape, whereas similar is, come on, Mr. Main. Okay, so two figures are congruent, then they are similar. So that means if I have two shapes that are exactly the same, like the two red ones that I drew here, they're congruent. Can we also call them similar?
Yes.
How often can we do that? Is it all the time, some of the time?
Some cases.
In some cases?
If they're congruent, then probably all the time.
Well,
In, what do you think?
But because they have the same side length and same area,
And what does similar mean?
they're kind of the same.
Same shape, right? Because these are same shape and size. This is same shape.
That would only be like sometimes.
so yeah, that would be in some cases.
It's sort of the opposite. So if we have shapes that are, if we have two shapes that are congruent, that means same size, same shape. We can also say that they are the same shape, right? Because if they're same size, same shape, then they're always going to be same shape. So we can always say congruent figures are similar figures, but now we want to think of it the opposite way. Now we're thinking about similar figures. If you have similar figures, then we can call them congruent. Can we always call similar figures congruent though?
No.
Can we sometimes?
Yes.
Yes. So for this one, we would say sometimes, because sometimes we have Annie, perfect. Sometimes we have shapes that are congruent. That's good. Sometimes we have shapes that are similar that are congruent, but not all the time. Because sometimes we have shapes that look like this that are just same shape, not necessarily the same size. So sometimes similar figures can be congruent, but not all the time. Okay? So please feel free if you're at home to throw things in the chat if you're not understanding what I'm saying or if you need me to explain it more. Nice job, Jaden. I love that response in there. I had it up, but nice job. Okay? Awesome. Thank you, Olivia. So this next page is actually Miss, oh my gosh, who was it? Miss Albert put that in because her kids are like less experienced with Zoom. So we don't need to go through those expectations because we know what we're doing. So if you're in your textbook still, now you're gonna look, you don't have to flip the page, you're gonna look at the page that looks like this. It's like right next door. If you are on the slide, slip and slide down to slide number 7. Let me see what Diego said. Give me 1 second, Diego.
Isn't that slide 5?
Yes, exactly, Diego. Yes, slide number 5. Didn't I say 5? What did I say?
7.
I meant 6 or 5. Oh my God. Oh my God. So yes, perfect. Nice job, Diego. So we're on slide number 5. If you don't have a text.
Mr. Lockhart, please call extension 3214.
Okay. So let's take a look at what Priya and Claire are saying about these squares and rhombuses. So we're thinking about what we know about similar and congruent figures, what has to be true. And let's look at what Priya is saying. So Priya is saying these polygons are similar because their side lengths are all the same. Okay? Claire is saying that the polygons are not similar because the angles are different. Who do we agree with, Priya or Claire? That's okay, Avery. What do we think? I want everybody at home to tell me, who do you agree with? Do you agree with Priya or do you agree with Claire? Throw it in the chat. Okay, I'm gonna keep tally of the score up here. I'm very competitive, so I like to keep track of things.
3 Claires.
Yes.
So we have three Claires, okay, so Claire
Someone said.
and Priya.
Someone said I kind of agree with. I don't know who that is.
I kind of agree with, let's see what Gabby thinks. She kind of agrees with Claire. Good, okay.
So
From far away, it looks like there.
Okay, Kaylee, what do you think? Who do you agree with, Claire or Priya? Okay, Alyssa, who do you agree with?
Claire. Claire.
Sir?
Ramadan, please go to room 132.
Seems very serious.
Claire, because because the angles are different.
There's right angles, and then there are some acute angles and some obtuse angles on the other.
Yeah, they can have the
Good.
same side length, but they're not
And
the similar,
You can-
similar shapes.
yeah, these are both polygons. There can be different types of polygons.
Exactly, Bridget. So we're gonna say we agree with Claire because, I think it's all clear, right? We agree with Claire because they're, in general, for them to be similar, they have to be the same what? Same shape, right? They have to be the same shape. So are these the same shape?
No.
No, they're not the same shape. They have different angle measures. Exactly what you guys were saying. Awesome. They are different shapes and have different angles. So we're saying that shapes cannot be similar if they have different angle measures. So that's a really important piece of this, is that to be considered similar shapes, all the corresponding or matching angles have to be the same measure. Does that make sense? Maybe? Okay. Okay, cool. The side lengths does not matter when we're talking about similar. We're talking and we're looking at the angle measures, okay? Awesome, awesome job. In your textbook, you should have this reason why and this answer to the question. So, in your text, it looks like this, and you should be writing down these reasons that we're talking about. Who do we agree with and why? And we put down Claire because they're not the same shape, okay? So now we're gonna look at these two rectangles. This one's a little bit more challenging. So we have two triangles in the next activity. Dang, wow, okay. I don't hate it. I don't hate it. Let's take a look at the next piece here. So you're on the same page in your textbook, but on the slides, you're moving to slide number 6, okay? So now we're gonna look at some rectangles, A, B, C, D, and E, F, G, H. Now, 2 more people are saying statements here. Jada is saying these rectangles are similar because all the side lengths differ by 2. Or what she's saying is you're adding 2 to each side. Think about that. And then Lynn is saying that these rectangles are similar. I can dilate AD and BC by 2 to get those side lengths. And then I can dilate CD and AB by a scale factor of 1.5 to get it to those matching corresponding sides on the new image. So she's saying, so it's just the scale factor. So yeah, she's just talking about the scale factor, but she's saying dilate these blue side lengths times 2, and then dilate the top side lengths by 1.5 to get it there. Do we agree with either Jada or Lynn? So first, let's think. Do we agree that these are similar figures?
They are similar figures.
So they're both rectangles, but remember they have to be. We have to multiply by the same scale factor for everything. Based on this multiplication here, so we have to multiply the bottom sides we multiply by 1.5 to get to 6, and then we multiply these side lengths of 2 times 2 to get here. Let me see what Diego's saying. D is right here, Diego. What do we know about when we dilate a figure? When we dilate a figure, Kaylee, we have to do what to all the side lengths?
You have to multiply by the scale factor.
And the scale factor is always going to be what?
The same.
The same. So if we look at this statement and we look at the math that we have to do here, can we say that they're similar? Are these two shapes similar?
No.
No, why do you think?
Well, the shorter side is by 2, and the other one would have to be by a different number.
So that means the scale factor is 1.5 and 2. Can I do that?
No, you can only have one scale factor.
You can only have one scale factor. So yes, they're both rectangles and they look relatively the same, but we need to test it. So you need to say to yourself, is there a number that I can multiply every single side by to get that larger or smaller number? So we're going to say, do we agree? We don't agree with either of them. They're both wrong. And why did we say we don't agree with them? Why are they wrong?
Because
They have 2 scale factors.
Because there's 2 scale factors. Yes, Avery, because we have 2 different scale factors. They're not proportional. The shapes are not proportional. Proportional means that you multiply every single side length by the same number. We didn't do that here, so they're not proportional. These shapes are not proportional. Let me see what's in that chat. Well, yes, Diego, that's the point. We said that the scale factor from 4 to 6, we had to multiply. If you look at the green color down here by the green line, we multiply by 1.5. So yes, it wouldn't. So that scale factor, if we look at the red sides, the scale factor would be 2, and the 2 does not take me from the 4 to the 6. Nice catch there, Diego. Fantastic. Okay. So when we have, I'm going to put in one extra slide here, and I want to just sort of hit everything home. Go ahead.
So wait, how is it neither of them if the first one said that you add?
Oh, let's go back to that. So, but she said that they are similar. If you look at Jada said they are similar, but we decided that they're not similar. Because what do we know about scale factor? When we're dilating a shape, we have to do what operation? We have to multiply. So, and this is saying add 2 to each side. And that's not the operation that we're doing here. So dilations, thank you for bringing that up. I brought that up in the last class, but I forgot. Dilations don't, D-O-N-T, don't include addition. So you can't say that they're similar because you add the same number to each side length. That's not what a dilation is. A dilation is taking each of the side lengths and multiplying by a scale factor, not adding it. Good catch there, Alyssa. Thank you for bringing that up. So, like I said, I want to come onto a blank slide, and we're going to look at one more set of figures that I'm going to sort of pull up just to look at real quick. We're only going to look at it for about 30 seconds, but I want to take a second to look at these. So I have a triangle here. No, I don't like that because it looks like an equilateral. Okay, and I have, okay. So I have let's look at these triangles here. So go back to the slideshow, back to the Zoom so that you can see me. I have two triangles here. I have the green one, I have the red one. Are these two triangles similar? Throw in the chat. Do you think that these two are similar? I'm going to do a tally, so everybody should give me an answer. Do you think that they are similar? Yes or no? Okay, so I have three people saying yes, one person saying no, another person saying yes. I think there was one more up there. Avery said yes. Good. Jaden said yes. Okay. Okay. What do you think, Sawyer?
Yeah.
Bridget?
Yes.
Alyssa?
Yes.
Kaylee?
Yes.
Okay, Kaylee's going to help me. Why do you think that they are similar? They look similar, but what do we have to test? We have to see if we can find a common, nice job, Avery, scale factor. So I need to say to myself, if I want to go from the small one to the big one, what do I have to multiply by? 2.5 times what gets me 5? Plus 2.5, so that's times how many times? Not 2.5 times, it's 2 times 2. So then now I'm going to look at another set of corresponding or matching sides here. What's the scale factor going to be between these sides? Sawyer? 2. And then if I look at these two last corresponding sides, what are we doing? Bridget?
It's gonna be times 2.
Times 2. So can we say that these guys are similar?
Yes.
Yes, very good. Because I didn't say anything about these angle measures, we could say 1, 1, 2, 2, 3, 3. They're the same. Nice job. Awesome. And I love that I took a minute to do this because I want to really hit home to you that, you know what, Jaden, that was really awesome what you said back there. I'm actually going to take a second to read it out. So Jaden said that yes, 2 is half of 4, 3 is half of 6, and 2.5 is half of 5. Jaden, that was really impressive. Awesome job there, my friend. Really good. So when you're given two shapes, you're not just going to look at them and say, yes, those are similar, or no, those are not similar. You have to test it. You have to say, between your corresponding sides, is there a number that I multiply by that gets me from one to the other? It has to be consistent between all of the corresponding or matching sides, like this one and this one. And then the last one would be this one and this one here, and this one here. Good, nice job, awesome. Really glad that I did that. Let's take a look at our next activity, okay? The next activity, we're gonna work on this for 7 minutes before we go out into the hall for our mask break. Actually, we're gonna go down in the atrium. So let's take a look at slide number 9, okay? You don't have this in your textbooks, so flip back to the Zoom so that we can see this, okay? We have 3 big ideas in this lesson here. Similar figures have congruent corresponding angles, congruent meaning the same size. So the corresponding angles are going to be the same, and proportional corresponding side lengths. Remember, proportional means times the same number. Proportional means all of the side lengths are multiplied by the same number, okay? Some figures, like rectangles or triangles, or rectangles or squares, it is sufficient to focus on the side lengths since the corresponding angles are automatically congruent. Because when you're looking at a square, you can always say that it's going to be 4 90-degree angles. So you can say that those angles are the same, And then you just need to look at, are those side lengths proportional? The opposite is also true. When you have a rhombus, remember a rhombus is like a square where all the side lengths are the same. It's sufficient to focus on the angles since the corresponding side lengths are automatically proportional. So if you have two rhombuses, right? So you have two rhombuses. You don't need to worry about the side lengths on the rhombuses. You just need to make sure that the angle measures match up. Right? So we're going to take a look at that angle portion piece. That was really in the first one that we were looking at. That we said that the square and that rhombus were not similar because those angle measures weren't the same. The angle measures need to be the same and the sides need to be proportional, multiplied by the same number. Ooh, I feel like we're doing really good at this. just me as a teacher. Good teacher vibes today. So in our textbook now, I want you to, in your textbook, if you have it, we're going to flip forward 5 pages. So flip forward 5 pages to the page that looks like this. It says Activity 3, similar figures in a regular pentagon. Okay, so it looks like this. And we're going to be looking at it on the slides in a moment. Activity, lesson number 8, activity number 3. Lesson number 8, activity number 3, similar figures in a regular pentagon. Okay? Fantastic. So, I have this guy here. Question? Huh? Oh yeah, fill out the form. Okay, so this diagram has several triangles that are similar to DJI. Let me grab my pen and let's look at triangle DJI. Okay, so there are a number of triangles that are similar to DJI. That means I'm going to find some ones that are bigger, and actually we're not going to find any that are smaller. So we're going to find 2 triangles that are similar in size to DJD. 3 different scale factors were used to make triangles that were similar to DJI. In the diagram, find at least 1 triangle of each size that is similar to DJI. So let me tell you what that means. So I have this triangle right here. I see it, another one right here that is similar. Triangle ACE. And the way that I like to read these angles, or the sides here, is by saying in alphabetical order, reading them in alphabetical order. So what I want you, there's a pentagon outside of the shape, then inside. So it does make a star, yes, Jaden. So your job is to find, this is the one that is the largest. And then there is going to be some that are the same as the red one, and then there's one that's going to be like in between, so middle. So I want you to take 2 minutes to look at this, and I want you to list out different triangles that are similar to DJI. I gave us one already, ACE, and I highlighted it. So what I want you to do for the next 2.5 minutes is list out some more triangles that are similar to DJI. Okay.
You said DJI?
Yep, it's the red one that I colored in on the if you go back to the Zoom.
All right.
And remember, similar can mean that they could be bigger, but they just have to have the same angles and proportional side lengths. So we got the I got the largest one here. Once you start finding triangles that are similar, start to throw them in the chat so that we can all look at all of them, and I can keep everybody included in the discussion. I'm writing them down for now, and then we're going to test them when we come back together. Alyssa.
ABF.
ABF. Okay. So keep writing them down, and we're going to come back together in about a minute. So give me 1 second, Alyssa. Okay. Nice job. BG. So now try to find some bigger ones. ICH, these are all the same. These are all congruent to this guy. I want you to push yourself, and I want you to see if you can find some that are bigger. Because there's one here that's bigger that I showed you. And then there's another one that's in between that inside. I want you to push yourself. You got this, kiddo. Oh, yes, perfect. Perfect. We found the middle guy. Throw some more in the chat. EJD. EJD. Okay, so we're going to start to go through these, and then we will take a break. Actually, you know what? We're going to take our mask break first. So my friends that are at home, we're actually going to mask break in the question.
I was gonna ask if I could just sit back down, we could still do the work and feel like we did last.
Would you guys want to do that?
Yes, and we could still do the work.
Okay, perfect. So why don't you grab Bill's desk? And then why don't you grab, wait, what is that? I know, wait, it's that.
Well, we can stay there for Sawyer with that.
Okay, so then Sawyer can move. Okay, perfect. Actually, we're not going to mask break. We're actually going to mask break while we work because we are super dedicated in this classroom. I love it. So let's take a look at some of these examples. So Avery said CAB. Let's check that guy out. CAB. Do we agree?
No.
Is that one similar? Why do we think that it's not similar?
Because it doesn't if you reflected it onto the shape, it won't.
It wouldn't fit perfectly, exactly. So like if we had reflected it, it wouldn't fit perfectly. But also if we look at these angle measures, right? Yes, like
Yeah, that's why it's like slanted and longer than all the other ones.
exactly right. These angle measures are not the same as these sort of corresponding ones would be. Good. Nice job, Jaden. That's a good comment there. Awesome. So CAB, sorry, not gonna work. ABD. Let's look at A, B, and then where's C? Oh, all the way up. Okay, perfect. This guy here. Yes, perfect. That is proportional by to this guy here. Very good job. Nice job. That was ABD. Let's see. Let's do one more. Alyssa, what was one that you had?
ABF.
ABF. Let's look at ABF. ABF. Very good. Very good. And that's that middle shaped one. Very good. Nice job. ABF. Okay. Let's see. Let's do more than just the three. We had ABF, which was here. Very good. ABD, which was here. What was another one? Go ahead.
CHI.
CHI. Let me erase over the top so that we can look at it. CHI. CHI. Very good. This guy here is very good. Nice job.
I have another one.
Bridget, help me out.
GHB.
GHB, let me do this one, CHI. We were gonna test that one next, Jaden, that's Cat, or Avery. Or we were gonna test it. Okay, so let's look at GHB. GHB, very good. And that one is similar to this one, and it would have a scale factor of, what do we think the scale factor would be? It's the same shape, same size, so it would have a scale factor of 1 because it didn't get bigger, it didn't get smaller, it would have a scale factor of 1. Good. Now, let's take a look at, Avery said EJD didn't work. Let's look at EJD just to make sure. EJ, oh, where's the, oh, she said this one here. And we already said, just like that one that was down below, it didn't work. Nice job, Avery, nice catch. The slant is wrong. Very good, those angle measures are wrong. Good, who had more?
Avery said FEA.
FEA, let's look at FEA. So FE and A. Avery, once again, my friend, we're not the same angle measures here. These angles are much smaller than these corresponding angles over here. Okay? If you think of another one, let us know, okay? E.
Is it?
Yes, what do you think?
Oh wait, someone already said. Wait, did someone say FEJ?
It's in your book, Avery, too, if you want to look at your book. What was it?
FEJ.
FEJ, yes, FEJ is 1, very good. FEJ, wonderful. Let's look at some more of those. We said this one here. Is there another one that's congruent to this guy that I just drew in right here? Because there's a couple more of these also. HDC. Oh my goodness. Okay. HD. Where's D?
It's on the right
Yes,
side.
that is.
Right
Oh,
side.
HDG.
No, E.
No, E. Very good. Nice job. Yes. But it wouldn't be H. It would be
HDC, she said.
oh,
yeah,
HDC. Very good. I'm dyslexia right now. Good. Perfect. Kaylee's gonna give us one. What do you think, Kaylee? CGB. Let's look. CGB. CGB. Yes, dude. Perfect. Sawyer, did you have another one that wasn't listed here?
No.
What if
What was the original shape again?
the original one was DJI?
No, the one we're doing now.
Oh, the original one was AEG.
Oh, that's okay. I have one.
Go ahead.
DEF.
DEF, very good. Okay, I have one that I'm going to ask. Lily, I want you to look at the one that I'm going to draw on here. What if I said DCH? What do you think about that one, Lily? Do you agree that that one is similar or no? Yes or no? Nice job, Lily. Yes, she agrees. It is similar. And the scale factor is going to be larger than 1 because the side length gets longer. Actually, let me draw on there. The side length gets longer. Very good. Nice job, Lily.
Oh, I have another one.
Another one. Go ahead, Button.
BIC.
BIC. Let's take a look. Let me erase, though, because I want to see. BIC. See, perfect, Miss Button. Perfect. Okay, so now the next piece of this, number 2 for this problem, is going to ask you, or actually it's letter B, it's going to ask you to list off triangles that are not similar to DJI. I want you to take a minute right now to list off some triangles that are not similar to DJI. We're looking at DJI. I want you to list off a couple triangles, 3 or 4, that are not similar to DJI. Throw them in the chat when you start to come up with some. job, Olivia. Let me write that down. We're going to check them, so I'm just going to write them for now, and then we can check them. C, E, G, C, H, B. Sawyer, I'm going to get one from you first. Sawyer's going to tell me what is one. Carter, I want you to throw one in the chat as well. Sawyer, which one do you think is not similar to this DJI? EFA. Very, very, very good. F. That's an F. Should be an F. Mr. Main, you got this. EFA. Good. Carter, I want to get one from you, dude. Put one in the chat. Bridget, help me out.
I put JCB.
JCB. Let me. JCB. Very good. Well, JCB wouldn't. JCB. What do we think? I think JCB was actually a copy of that original. No, not a big deal. Not a big deal. This is very tricky. Kaylee. DCB. DCB. Very, very, very good. Nice job, Kaylee. Impressive. Impressive stuff. I'm going to test one of these, and I'm going to come back to you, Alyssa.
Sure.
CEG. Let's take a look at CEG. What was yours again, Kaylee? Can you read it to me again?
DCB.
DCB. Nice job. Wonderful. CEG. Let's take a look at CEG. CEG. Fantastic. Nice job. CEG. Miss Button, what do you think?
ACG.
AC.
No, ACJ.
ACJ. Okay, let's take a look. ACJ. I love it. Fantastic job. Nice job, Alyssa. ACJ. Very good. Oh, no. Okay. Let's test one of these, and then we can go to that one. CHB. Let's look at CHB. CHB. That one's not very good. CHB. Who wants to give me another one? Go ahead, Sawyer. Help me out. EBI. Let's look. Oh goodness. Let's see. E is here. EBI. Very good, Sawyer. EBI. So, ladies and gentlemen, this is kind of a fun activity for me. I love this activity because everybody gets super into it, and everybody did get, look at that, we just listed off like 9 different ones. And now we're just in like a 2-minute span of time. So awesome, awesome job today with this. What we are gonna do to finish off today, for homework this evening, if you look in the classroom, I'm gonna pull it up, just give me 1 second. We have a homework assignment today. The homework assignment is the cool down for today. I just minimized the chat, just give me 1 second. Actually, I'm gonna pull it back up because I don't really feel comfortable leaving it out there for you guys. So we're in our task for today. If we're in our classroom and we go to class 3, right, we go to classwork. Under our heading for 10:29 to 10:30, we have the 10:30 homework. I want you to click on that. And it is a cool down. I don't know why so many people already turned it in. It has 3 questions on it. First, why are these rectangles not similar? So you got to tell me in this answer here, why are these not similar triangles? Think about how they have to be proportional, and think about what proportional means, okay? Then, why are these 2 shapes similar? Why are they similar? What's the same about these 2 shapes? And are these 2 shapes similar? Yes or no? And why or why not? Okay?
Slide in, right?
Hmm?
turn this slide in?
Yep, and then once you finish, you can turn the slides in for today. And then once you finish the cool down, you can go in and hit turn in on the cool down, okay? Does anybody at home have questions? Yes, you can come back to your seat. Does anybody at home have questions? Throw them in the chat if you do. If you are at home, please make sure that you put your textbook back in your backpack. You will need it in school on Monday. Okay? Make sure it gets back here.
Is the link in the slides the same as?
Yes. Diego is here. Ethan is here. Gabby is here. Isabella is here. Jaden is here. Lily is here. Olivia is here. I'll write that down. Okay, Olivia's here. Good. And Billy is here. Okay. So my friends at home, once you finish this exit slip, you can head out or log out of this session. I will be posting a link to the, I'm going to be uploading this video to YouTube so that you can refer back to it. I mean, you don't have to rewatch it like if you were here, but it's just going to be available if later on you want to refer back. It will be available. Okay, so you guys can head out once you finish your exit slip. Awesome job today. You don't have to do anything else on the slides. I'll share my YouTube later, okay, Diego, on when I post the video after school, okay? Have a fantastic weekend. Be safe if you're going out trick-or-treating. Make sure you're keeping that social distance and just being safe, okay? Gosh, I feel like my mother when I say.
I'm trying to walk on the sidewalk.
Awesome job, everybody. Have a fantastic, yes, in classroom, I'm gonna post it on the stream, on the classroom stream where I post all the other ones. Okay, hey Diego, that's pretty cool, dude. Okay, I am going to, and have a good one, Avery. Bye, guys. Let me know if you need anything, either Olivia or Brando. No? Okay, I will see you guys on Monday then, okay? Have a great weekend, okay? Be safe, have fun. Stay fun and clean. Bye, Olivia.